Dr. Soumitra, good afternoon.
Good afternoon. Good afternoon.
So thank you. Accept our invitation in a short notice. So let me introduce yourself, then you can start.
Okay.
So today we have with us Dr. Soumitra Ghosh. He is going to give a talk on leveraging AI sensitive domains, advances in clinical text analysis. And Dr. Soumitra is a researcher in NLP, machine learning, and AI with a strong focus on the healthcare and clinical text analytics. So he earned his PhD in computer science and engineering from IIT Patna, where he was associated with AI, NLP, ML research under the guidance of the NLP researcher like Asif sir and others. So his research span clinical NLP mainly and medical dialogue system, sentiment and emotion analysis, multilingual NLP and trustworthy AI for sensitive domains. Currently is a researcher with NLP research unit. I think some Bruno Kessler related to that one.
Yes,
And
yes.
sir will tell you in details. He's going to be joined at IIT BHU very soon. So, sir, thank you very much. Now, session is yours. You can start and you can give more introduction about you.
Okay. Okay. Thank you. Thank you so much. Uh, so I have 1.5 hours, right, for this
Yes, yes,
session?
yes, sir.
Okay. Okay. And so all the participants are online or they are
Oh,
offline?
yes, yes, online.
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 Okay. Okay.
Students are joining and all are online.
Okay. So before I start, let me just share my screen. And
Yes, yes. I've already made you the co-host. So,
okay. Okay. Mm, let me know if my screen is visible. Is it visible now?
visible.
Okay. And can you confirm if the slides are moving?
Yes, yes, yes.
Okay. 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 Thank you.
Make it full screen and start.
Yes, yes, yes. Okay, so first of all, thank you very much for having me today. Thanks to the organizing committee and especially Dean School of Computer Applications for this kind invitation. And I must say that I just checked the schedule and the sessions that have been organized. They are really very intuitive given the current scenario in AI NLP. And I believe that the participants are really it has been enriching. All the sessions have been quite enriching for them, and they are definitely learning a lot from this workshop. And quickly, one or two lines about me. I just joined IIT BHU last week as an assistant professor in the Department of Computer Science and Engineering. Prior joining IIT BHU, I was a postdoc researcher at Bruno Kessler Foundation in Italy for about 3 years, where I have been mostly working on information extraction in the medical domain and particularly focusing clinical NLP on rare cancer to be specific. And so today's seminar, mostly I will be discussing topics on or particularly two objectives or two topics that I had worked on during my postdoctoral commitments. And mostly this is relevant for this particular workshop or for this particular session is that both of these topics were focused towards low resource language or low resource in general in the medical domain. Okay. So I think that today's seminar or the things that I will be discussing, uh, I think is the screen still shared? I don't see it. Just a minute.
The screen has gone.
Yes, yes, I didn't see the screen. Is it visible now?
Yes, yes, visible.
Okay. 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 Yeah, so enough about the introduction. So these are the couple of topics that we'll be focusing on today. Uh, the first one related to this project eCream, which is a European funded project, tenure of 5 years. And in this project, I was kind of a part-time, I had a part-time association in a small module for that work. But then I will go on discussing another work related to this project idea for RC, which is a 4-year European Horizon project, in which I was the main resource person who was more working on the NLP aspect. Okay. So the the first topic, okay. So before I begin with the topic, so feel free to stop me anywhere wherever you feel like asking questions, or do you have any suggestions, comments, or clarifications? Just let me know. I don't know if I can see if you raise your hand, but at least I think sir can stop me and just tell that there are some questions. Okay. So the first topic is that semi-automatic translation and projection of clinical cases. So before I go into what we did in this particular area, or in this, what was the objective that we were trying to solve. So to give some context, so there is a very important clinical resource that is a European Clinical Case Corpus, E3C, okay, which was introduced by Bruno Kessler Foundation like years back, or maybe in somewhere in the 2000s. And it is the most important clinical resource that is publicly available on medical documents and clinical cases. Okay? But initially, when the resource was distributed, it was only distributed for these 5 languages: English, French, Italian, Spanish, and Basque. Okay. So now the situation came in the context of this project eCream. The situation was put in the proposal that we should have a similar kind of resource, but for the low resource languages, low resource European languages, okay, such as Greek, Polish, Slovak, Slovenian. So like these languages are really low resource when compared to Spanish or English or Italian even, we can consider. Okay. So now to have this corpora, a similar type of corpora in those low resource languages, so that was the goal towards which we are working in this particular topic. Okay. So now I think broadly speaking, we know that what we are trying to achieve. So we have some existing corpora, which is in some high resource language, but now we want to develop a similar corpora. Corpora is just a data set or a resource, okay, meant to develop NLP models or train LLMs. Okay, so those corpora should be there for the low resource language such as Slovak, Slovenian, Greek, and Polish. This is our end goal. So to give you some more details about what the original E3C corpus had, it had this type of annotations, okay, which were done for an extensive period by both clinicians and expert annotators. And there were multiple entity types such as clinical entity. Say, for example, if you are marking fever or something related to some disease, so it is a clinical entity. Then event is something like having a surgery, okay, or being discharged from the hospital. So these are events. So those type of annotations were marked in the E3C corpus. Similarly, actors mean when there is a mention of a patient, okay, so that entity is called an actor. Similarly, if there is a mention of a body part, so cancer in throat, okay, so that throat is the body part. So and timex is the temporal relation. So if there is a mention of some temporality or related to time, that the patient was discharged after 5 days, so that 5 days becomes a timex entry. So these type of various entities were marked in the original European Clinical Case Corpus. Okay, so there are other annotations which is not which can be considered out of the scope for now. But just keep in mind that these are the all sorts of annotations that were already there. Now we want to now, since the demand of E3C has been so much that people want, and now that the LLMs are so many in the public forum, like there are open source LLMs everywhere. So if we have some corpus in a low resource language, maybe we can train an LLM and like solve some particular task. But the challenge is we do not have the corpora for those low resource languages. So that gave us the opportunity to use this clinical case corpus that was already there and somehow design a methodology, okay, and bring up the parallel corpora in the low resource languages. Okay. So this is what I was talking about. So clinical entity means any disorder, pathology, symptoms, body part is the parts of the human body. And these are some of the examples directly from the corpus that how, so ITP is something, a clinical entity, which even I don't know, but let's assume that this is a clinical entity. Then this is some test results. So it comes under RML entity. Then actor, as I said, that it mentions some patient or some human entity. Okay. Similarly, timex is where the temporal aspect is there. So this type of these are some examples of these various annotations. To help us understand how the data actually looks is that uh, so it this particular slide has been projected through a third-party tool known as Webarno, okay, which helps us to visualize the annotations that we are discussing right now. Okay, so E3C is a quite complex corpus. Complex in the sense that it has a lot of annotations. It has a lot of annotations for various entities and also a lot of annotations for relations among those entities. So all those are held in a particular format, which is XMI, which I will discuss in the next slide. But just for now, understand that it is a very complex corpus having lot of things interrelated, okay, and which is very difficult if you see the raw files. If you see the raw data files, you cannot make sense out of it. Okay, so this is a tool Vivano which gives a lot of sense to from as at least from the user perspective to understand how the data actually looks like. So if we read as a plain English sentence, a 14-year-old boy with no significant past medical history and something so on and so forth. And the entities are marked by some different colors. So this is a actor, that is a patient. Here, this is a event. Okay, this is a event in blue. Then again, this is a timex because it denotes time. Then there are clinical entities marked in orange, abdominal pains, then reduced urine. So likewise, and there is if there is a test result somewhere mentioned, it is a RML. So looking at this, it seems quite easy to understand the data, right? So that is why Webano was built. Like Webano, so Webano is not only for projecting, but also for annotating this type of data. But if you see the backend, if you see the raw files, it looks something like this. Okay. So now if I say that, tell me that where is this 14-year patient annotated, or where is this facial puffiness annotated as clinical entity from this raw format, XMI format? So what is XMI? XMI is derived from XML, which is extensible markup language, and this XML is particularly used for writing the details of data models. Or if you are aware of DBMS, so you know what a relational database is. So we have a relational schema. So if you have to write the details of that schema, this is just an example. Okay, it's not like we write relational schema in XML, but this is quite similar to something that I'm trying to tell you. So if you want to write the schema for a data model, you use the XML language. Okay, and XMI is nothing but XML metadata interchange. So for now, just understand that XMI is used to write the schema or the structure of a data model. Okay. So this is how the actual data set or one data point from the data set looks like. And believe me, everything that you see here, so and this is for only 2 sentences, and this medical record can be of 80 sentences long or maybe 15 sentences long. Okay. And all these annotations with the text and all these type of entities are somewhere marked in some order over here. Okay. So so as a human, so like as an end user, if someone brings this slide to me, so definitely I won't be able to understand even 5% of it, what they are trying to show. But if they show me this, it is more human understandable. Okay, so I think everyone will agree with that. Now the goal is that so if you remember, I said the broad objective is that we want to have this particular data in a different language. That is a target language, and that target language is low resource in nature. So maybe that language is Greek. Okay, and if you look in general, if you look at Greek data sets, they are very rare to find. You won't find Greek data sets even for maybe some handful samples for even sentiment and emotion, which is a very popular task in NLP. okay, in deep learning as such. So even for sentiment emotion, which is a very established task, you won't find much data for Greek. And coming to this domain of medical field or clinical NLP, it's understood that naturally you won't find any data related to Greek for this particular scenario. Okay. And I think I forgot to mention that even if we are in the medical domain, the task is even challenging because we are targeting a very particular specific area of medical domain, which is rare cancer. So as the name suggests that it is already rare in nature, so obviously we won't have enough medical records or documents even to support those cases for rare cancer. So even if you are in touch with some hospitals like we did, but even they don't have much cases or documents related to rare cancer. So that is why this task is so challenging, right? So our goal is to generate this particular data in a new language, say for Greek, okay, where the text should be converted to Greek and all these annotations should be correctly placed in the new language. Now, with our common sense, we can understand that if I say something in English, okay, it cannot be, and if I convert it to say Udia, okay, so there can be some extra words or maybe less number of words than the English sentence, although the meaning is same, right? Because there is no direct relation between each word in English to the each word in Udia or any other language. So there can be 5 words in that English sentence and there can be 4 words in the Udia sentence. So now in this English sentence, if history is marked with some entity, and for example, just take for consideration that in the when you convert the sentence in Udia, and this particular word breaks into 2 words. Okay. So our goal is that this particular entity should be marked across the 2 words in the Udia language. Okay. So I think this is clear. So what I'm trying to say. So it's not just converting the text into Greek from English, but also placing the annotations at the right places in the new target language, which is the main challenge. Okay. So, and naturally I said that we
But
have
we
this
call it
document.
alignment, right?
Yes.
This is
Sorry.
only known as alignment, right, sir?
Right. Exactly. So I'm talking about the alignment issue. So there is no direct alignment. So even if we do sequence to sequence tasks, so we are very aware of the alignment difficulty, right? So this is purely alignment that I'm talking about. So now our goal is to generate this exact document, but this time in Greek. This is in English. I want to prepare a similar document in Greek that holds all the annotations, all the entities that I showed in the previous slide with and like this if you see in the bottom of this slide, so we report a 9-year-old male child. This is the whole medical document without the annotations, and the annotations are marked somewhere here in some XMI format. Okay, I want this exact document to be in Greek, so this whole text should become Greek. That is fine. I think that is easy. Even if you give to ChatGPT or any LLM, it can give a very good output in Greek. But the main challenge is whether it is able to transport the annotations at the right place in the Greek language. Okay, so to make things clear, so this is something that I already discussed. So this is the objective. So we want to develop an automatic procedure that can do this particular task, that translates the clinical, just a minute. Okay, so that translates the clinical cases from English to a new language, low resource language. Okay, so first thing is that, so okay, before going to the steps, let me show. So what comes in your mind right now? Staying like today, what if I present you this task? What will be the easiest way? I mean that you can think of, or what is the natural way that you're like if you have a system in front of you, what will your brain tell you to do this type of task? Anyone?
So repeat the question, please.
So if the task is clear, right? I want to develop a corpus, okay, like similar to this, but in a Greek language, which should correctly propagate or correctly transfer the annotations at the right places in the Greek language. This is the task.
Yes, sir.
Okay. So now what comes naturally? Like don't stress too much. Like what comes naturally? I mean, even if you write something, what do we do now nowadays? We go to ChatGPT,
Yes.
right? So I mean, it's true. Like even I do, like not for writing silly stuff, but even I use ChatGPT a lot. But for many different. So this is a natural thing to do right now. So let's see whether ChatGPT can do it for us. Okay, this is the natural way to go. So and that is what you tried also. Okay, when we are just doing the feasibility analysis of this work, we tried the same thing. Instead of ChatGPT, we tried the like the backend model GPT. I think three. We started with three, but then I think the best results we produced later on, I will show you, that was on GPT-4. Anyway, so we because we had the license of GPT-3 through our lab, so we use GPT-3 to see that whether it can do this particular task and to how much good performance it is able to give us. But the catch is we do not, obviously, this is something that you are seeing right now in this slide is through a tool called Webano. The data is not like this. The data is actually in this way, in this format. So the goal for ChatGPT is that to explain the task, definitely I explain the task to ChatGPT or for GPT in general, but then I present this XMI document, okay, and ask it to convert this same document into Greek, maintaining all the annotations at the right places. Okay, so this is a task of translation as well as projection. Am I clear? So why translation? Translation is because I want this medical note translated to the new language. For us, it is Greek right now. And all those annotations should be projected at the right places in the target language. So it is translation plus projection. And in the process, it should maintain the, I mean, the structure of this document in the XMI format. So the performance, believe me, the
How would we
performance.
know that which words to be projected? For instance, generally we use a normal transformer model as attention, give attention, and that token will be projected. So here already that attended more weighted word has been picked up, like history presented. So that will be projected. Is it right?
So, so let me just understand. You are trying to say that how the model will know that which words to project, right?
Yes, yes, yes.
So, in the XMI document, the already like this is something that we're visualizing very easily, but somewhere in this XMI document, there is the start and end offset. Okay, that denotes that where in the full text this history word occurs. Say, for example, this is a single line. Okay, and the start offset of history is maybe after 35 character and it ends at 41 character. So to denote that word history, we say that, okay, offset start is 35 and offset end is 41. That denotes history, which is a type of clinical event. Okay, so in this way, the XMI document holds all these type of annotations. So now I think what you're saying that, so all these annotations that are there are somewhere in the XMI in this offset format. I want ChatGPT to transfer everything, whatever it is seeing in the XMI. So for me as a prompt engineer, say for example, I'm not fine tuning. So as a prompt engineer, I'm giving my best prompt to it to make it understand the task and saying that this is a clinical case corpus where it holds this type of entities, this type of annotations. I want you to project this corpus exactly in the same format, okay, but in the Greek language and essentially transferring all the annotations at the right places in the target language. So in the target language, I don't know what is history means in Greek, but whatever it is, that particular word in Greek should be marked with a event. Similarly, where the facial puffiness is converted in Greek, it should be enclosed by this clinical entity. Okay.
Yes, sir, got it. Yes, sir.
There may be some doubt, but it will be more clear when I just show you some of the. So see, for if I am finding it difficult to explain to you, just understand how difficult it is to make it explain to a chatbot or this LLM. Are you getting my point? It is
Yes,
very
yes,
difficult. Even the best
yes.
prompt engineer or type of prompting may not be accurate for ChatGPT to understand what you are trying to say because a lot of complexities are there. So, and our expectation was that ChatGPT will do us great. If we just provide the XMI with our base prompt and it can give us a Greek language equivalent in XMI
Yes.
format, and
We
we
generally
will
provide the screenshot. Text
no.
with image. Yes.
Now okay. Now there is another challenge. So maybe for this, okay, so this is something, this is a snippet of the whole XMI document. Okay, so this XMI document, if I put it in a doc file, it will be 3 pages. So you cannot take a single screenshot of the whole thing. And if you break it into multiple screenshots, then automatically ChatGPT hallucinates.
Yes,
Okay,
yes.
this is a problem. So it's better to then, in that case, it's better to give the whole document.
Yes, yes.
Okay, but this is a very simple, this is a very small document. There are also some documents which are, I would say, like 80 sentences long. So I think this particular document is having only, you can see that this is the whole text, maybe 3 or 4 sentences altogether. Okay,
It's
but
fine.
there are sentences, there are documents which are 50 sentences long. So naturally, it will have more number of pages. Fine. So now
Yes.
the thing is that we initially tried to do this, like we uploaded the whole document, we expected ChatGPT to give the output and we should be happy and run our own models. This was the initial expectation. So, and to tell me what was the result was absolutely bad. So naturally, like I mean, I won't even say like it was of any acceptable quality, because there were errors in translation. There were most number of errors were in transporting the annotations to correct locations in the new language. Okay, even there were missing annotations. So maybe that particular history word that was there, maybe it was not even annotated in the new language. Okay, so those were cases of missing annotations. And there were another cases where the annotations were projected, but at the wrong place. Say, for example, I say that, okay, there was a cricket match yesterday, and I wanted this cricket match to be annotated, but it annotated match and the next word. Okay, match yesterday. So it is I can't say that it is a missing case. It is a mismatch case, because I wanted the annotation to be across cricket match, but it actually shifted to the next word, match and yesterday. So this is the case. These were the most number of error cases that we found. So one is a case of missing, where the entire annotation was it was totally gone. Okay, so missed in translation or in transmission, and then the cases of mismatches. And then also there was some quality in issue of translation. But I think if we compare the output of the projection, I think translation was pretty fine. So we should be happy with the translation. And we know that ChatGPT and all these tools are very well capable to translate in a different language. Okay, so that they were doing quite well.
Excuse me, sir. Sorry to
Yes.
interrupt you.
No, no.
Sir, yeah, just as you told me, RAX semi file we are giving input for translation and projection, right?
Right.
So, can we do, just I'm asking, can we
Hmm.
do wave annotation to as input to the translation, as wave annotation give the English sentence, right?
No, web
So,
annotation in
is it
what
possible?
sense? In
Yeah.
how? In
Means,
what format?
means in place of the XMI, as a wave annotation is giving, after passing the SMI is giving the wave annotation output,
You
right?
mean this one?
Yeah, this one, yeah.
No,
Can
but
we do
this
this
is
as a input?
no. That is
Okay.
what I mentioned, maybe, but I should have discussed more. So this is something that this Webano tool is helping us to visualize from the end user perspective. But when you download this annotation from Webano, it has to be downloaded in some standard format like CSV or XMI format or some other format or TXT format. But this type of document has to be downloaded in XMI format, because TXT format cannot hold all this type of information.
No, I am
CSV.
saying is after that, after this process done, can we now in this stage, can we translate and project, that I am asking? Is it possible?
So I know, I think I lost you. So this is so this document, we have this document. Okay. So this is the first document. This is not
Mhm.
the first case. So to make you understand, I showed this slide before. So this
No,
is the
now, sir, I am asking in this
Mhm.
stage, this one, and no, after wave annotation.
This is not web annotation. This is just
This one is
visualized.
yeah, this is the acha, okay. This is visualization,
Just visualized.
but we are getting from the output of wave annotation, right?
No, 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 no. It is
Wave
not an
annotation
output.
tool.
It is not an output. So this is the actual data. Okay. Now
Okay.
for a human being, or he is not an expert in XMI, it is very difficult to understand what this data is saying. This Webano tool is just helping us to visualize the data. So this is just visual, and this is no format, because to download something, it has to be in some format, right? some doc
Okay, sir,
file,
got it. Okay, sir. I
PDF,
thought that
PDF.
after that we can translate. I thought that maybe after CAT that we can translate and
No,
project.
yes. So even so, if I will now I am coming to your point. Okay, so the maybe okay. So for now you just see that this Webano is just a visualization tool. Okay, so there is no format in this easy structure. Even so, how say for example, in what format you would in what format you would put this 14 years? Say for example, this particular annotation around history. So if I say like the formats that you already know, maybe TXT, CSV, these are you definitely know. Okay, so if I say that you save this file in one of those format, then how you will enclose these annotations in that format? Can you tell me? Choose any format you like, text, doc, or any format. So if I say that the facial puffiness should be marked as a clinical entity, the abdominal pain should be marked as clinical entity, 4 days should be marked as duration.
So like we do in dictionary from JSON format.
So JSON is a way. JSON is a way. Okay.
Yes.
JSON is a way. Now, so this is a more acceptable format than TXT or CSV. Okay, JSON is a way. Now to say that we have so I didn't tell about these relations. We have these relations annotated as well. Now, what are these relations? These relations are relations among these various entities. Okay, so in JSON, I am not saying it is not doable, but how easy it is so we know that we can annotate the entities, but how easy it is to represent in JSON the relations between different entities within an annotation. Say
Yes,
an event
but
is
it's
related
difficult.
to an event is related to a timex. Say for example, a event surgery is related to a timex entity that is 5 days before, something like that, and that relation has to be also there in JSON format. I'm not saying it is not doable, but it becomes more difficult, right? So that is why this XMI format was developed to annotate this kind of data, which can hold a lot of metadata information about data and different dependencies among the annotations. This is a good point that we are discussing right now. That why do we need XMI when you have already this popular format? Because of these complexities, we need to this XMI is more suitable to represent this kind of annotations. Okay. So now, so I have a lot of slides, but we can discuss maybe
Yes, sir. Please move, sir.
yes.
Yes.
So after the first objective we have discussed, even I will take a 5-minute break. In that time, we can discuss more. Okay. So now, we fed this our input in XMI format to ChatGPT, and it was doing terribly. Like nothing was good. Okay. So we had to ditch this idea, and we had to do it some in because we have promised that we need to do some automation in this process. We cannot do it manually. So we have to find a automated way to do so. So what we thought that, okay, let's simplify this task for ChatGPT. Instead of XMI, now coming to the, I think the query, I think the other guy was asking was that whether we can provide this in text format. This is what something we did. Okay, so that was a very good point. I don't know whether you were trying to mean exactly that, but it was a good point. So what we thought that let's simplify the task for ChatGPT. So instead of this XMI, so maybe ChatGPT is confusing a lot of structure and all. So let's just simplify it and write in most English-like format. So there is this plain text, and wherever there is a annotation, okay, we design these tags. So this is an actor, this is an event, BO is body part, CL is clinical entity. And like we are aware of HTML tags, we just enclose that particular word or a span of words within the relevant tags. Okay. So now I think this is much more even human readable than the reading from XMI. This will acknowledge, right? So if you see that a 20-year-old right-handed female factory worker with no medical something, we can even read in plain English, and also we can understand, okay, this history is marked between these two opening tag and end tag, which is an event. We do not know, we do not need to go into the what is a number and all. That is even not in the scope of my knowledge. Okay, this is something that Webano generated for us. But anyway, this is out of scope for this discussion. So this is much more human readable, and also we believe that ChatGPT should understand in a better way compared to the XMI. And our anticipation was right. So what we did, instead of giving the XMI, we gave and this structure we call as inline. Okay, so this is structure we call standoff, and this textual structure we call inline. So and this, since this is a source language, So we call it source inline. So now we give the source inline as an input to an LLM or GPT-3, and we expect to output the target inline. And the target language is Greek, we must remember. So now you see that the output is quite better. Yeah, although I didn't show you the output of the XMI because it was so bad, but anyway, if you can make sense that, okay, it is doing at least something. So I find that AC3941 tag is here, and it was also there in the original text, and we can believe, okay, it is doing good. Okay, there are issues, there are missing annotations, there are mismatches. So let me cover a few parts, but those were issues, but the major issue was solved. It was finding difficult to understand XMI. We have solved the issue. Now the second task is to again regenerate the XMI structure. Okay, so this is where we did it manually, not by hand, but writing a Python script. So this conversion of standoff to inline, we just wrote a Python script, which is not, I won't say difficult, but it was very complex because all those dependencies among the annotations had to be taken care of, and it took even a lot of time to design the Python script that breaks down the structure of XMI and convert it into a plain text form like source inline. And again, we again did a Python script that can take this target inline and generate the target standoff in XMI. And now that we have the XMI format, we can again use Webarno tool to visualize the output in Greek. Okay. So in this way, so there are errors, still there are errors. I am not saying it is error free, there are errors, but at least now we are to good extent, we are able to generate the XMI from XMI to a new XMI in a new language, maintaining most of the annotations with a very minimal missing tags or mismatches cases. And to sum up everything, this is the overall structure, overall methodology. So we had the source annotation in the source standoff, okay, which is in the XMI format. We convert it to this inline source format. That is this one, okay. We pass this input to ChatGPT or GPT in general, which does for us the translation as well as the projection. And then again, we manually using a script, Python script, we convert this target inline to target standoff, which is again in XMI. So these are the main three modules. But at the end, there was this essential module, which is manual validation, which is very important because, as I said, that there were definitely some errors. There were still some missing tags. There were still some mismatches that happened. Okay. And those had to be fixed because we are working on a sensitive field, sensitive domain. So there cannot, the implications are quite high. The risks are quite high. So we cannot leave without fixing those issues. So there we contacted domain expert and we contacted language experts in the target language. Say, for example, we are considering Greek. So we took help of some Greek expert to solve, and they should not be expert in only in Greek, but they has to be clinician as well, because otherwise they won't understand what these details of clinical details are about, right? So that person has to be understanding Greek as well as he or she has to be clinician. And that person helped us to identify and fix all the errors that were inducted in this particular process. Okay. So what we achieved, this is what I was talking about. Just quickly, I will go through this. So this is a source inline and this is a target inline. So what do you mean by missing? Say, I think, okay, this one. If you see this tag event 1908, that is gastrectomy, and event close. So this event 1908 is totally missing in the target inline. So I think there is this gastrectomia. Okay, this is something in Italian. So ideally, this EV1908 should be somewhere in and around gastrectomia, but that tag is totally missing. So this is a case of missing annotation. And another case is mismatch tag, which in this particular case there are none. But for example, say for example, if okay, okay, so this actor, the patient, we see that in the Greek it is il paziente, okay, which is correct. But say for example, if in the Greek annotation it missed out il, and it only took this paziente in account. So then it is a case of mismatch because the entire span is not covered for that particular annotation. So this is a case of mismatch. So why these things are important, missing and mismatch? Because there is no clear metric by which we can clearly measure the efficiency of our approach. Because we do not have a gold reference. We do not have a reference because without reference it's very difficult. So initially our idea can be that we use blue or rouge if we are aware, which requires some reference text. You have some target text, you have some input text, and you should have some reference text to compute blue or rouge. Okay, so we do not have a reference text. So what we thought of that, since we do not have reference text, so once we generate this target inline, we back translate it to English again. Listen carefully. So once we have this target inline, just to understand that how efficiently this GPT model has done this translation and projection, we retranslate or back translate it to English, and then calculate the BERT score between the original English and the back translated English. And if we see that there is a good correlation and a high BERT score achieved between these two texts, we can fairly confidently say that the translation generated from GPT is of acceptable in nature. We agree? Okay, so these are some measures that we took, but it's already 45 minutes now. I want to cover another objective, another task. So I'm slightly hurrying here, but this is the end result that we got. So initially, if you remember, the E3C corpus was distributed in Spanish, French, Basque, English, and Italian. Now, using this strategy and using the source as English, okay, we didn't consider Spanish, French, Basque, and Italian. We started with English as source, and we generated the parallel corpora in Greek, in Polish, in Slovak, and Slovenian. So these are under projected from English. And now you can say that why this Italian is common in both the columns. Okay, this is because when we started this work, we had to know that whether there is potential in this work, whether we are capable to do this, or whatever we are thinking it would give us some output or not. And because no one in our lab knew this Polish, Slovak, Slovenian, or Greek, okay, and I don't know even Italian, but I was working in Italian lab, so they at least knew Italian. So while doing the feasibility study, so they tried to do the same approach from English to a parallel corpora in Italian. And since we already had the original Italian, we can directly compare that the performance of generated Italian and with the original Italian. And once we are sure, okay, the generated quality is of acceptable quality compared to the original Italian, we can go ahead with the other languages. So this is the reason why we see that entry for Italian in both these columns. Okay. So if you have questions, just ask me now. Then I will move on to the next topic. And this work, particularly like the technical details of this work, has been submitted in LREV, which is a popular journal. But if you want to see the methodology and all, that is already published in this work, Frontiers in Disaster and Emergency Medicine. Now, the difficulty with publishing research articles in the medical domain is that you cannot make the data public. And now without data, it brings down the contribution a lot. So even people who are researching, like most of you are researchers, I believe. So you will know that the importance of data, or the chances of acceptance when you provide a data as well as a methodology in your research article, right?
Yes,
But
yes, sir.
right.
Sir, one thing, can we do the same approach for low resource Indic languages like
Yes,
Odia,
definitely,
Marathi,
definitely.
Gujarati,
Yes, yes,
and
yes,
that
sure.
too
See, you can
other
exactly
tasks?
use this. So this is a general structure. But okay, but the catch is that if you want to directly use this methodology, so this methodology directly starts from XMI. Okay, but you can this pipeline will hold for converting to Indic language as well. You start with any format that this Indic language, or maybe English to Indic language. So you start with any format the Indic data, the English data is in. For example, JSON. I'm taking your format. Okay, and you can use this pipeline. If it is already easier for ChatGPT to understand, you do not need the help of GPT for translation. But if it is already in complex format, or maybe even in JSON, it is very complex for GPT to understand, or it is making a lot of errors. You can use GPT in between and simplify the task, and then you generate in the Indic languages in the target inline. Not inline, but in general target language.
Yes,
It is
sir.
not meant to only work for European language. It is just for low resource language.
Yes.
Okay. And another challenge for the ChatGPT was that even if you give a simplified structure, it does not have, it is not well trained on Greek, Slovak, Slovenian, like it is trained for English, Spanish, Italian. Right. So similarly for Indic languages, obviously we cannot expect it to have a lot of data on Maithili as it has data on Hindi. So now if we want to generate something in Maithili and we totally rely on GPT, it is bound to make a lot of errors. But if we maybe want to generate something in Hindi, maybe it will do reasonably well. Right. So any questions so far? Okay, so let me go ahead. So the first objective, I will end there. So coming to the next problem statement, which again pertains to, okay, so this particular, when I was talking about rare cancer, it concerns this particular problem statement or objective that I'm trying to discuss now. In the previous case, the challenge was that the target languages were low resource. Okay, so there the target was not that we are working in a very specific part of medical domain or sensitive part of medical. It was in a medical domain, but the main challenge was not the resource, but the resource was low, like very scarcely available. Okay, but in this particular case, the challenge is that the type of data itself is very challenging because we are talking about rare cancer. Even the hospitals do not see a lot of cases of like patients having rare cancer, right? So naturally, they do not have like enough medical records. Even if they are collaborative to help us with building NLP and using AI in medical domain. Okay, so here the main challenge is the type of data. So the task is clinical annotation generation from unstructured medical notes. And this is in the scope of this idea for RC project, but it is something we do not need to, it does not concern us right now. So I have most number of slides in this part. So I will slightly hurry, and also I will skip a lot of slides maybe just to give you the overall idea. But if you like, if I feel like you from your questions that you are going into some particular specific, which I already have in one slide, maybe I will then pick that slide and discuss. Okay. So for now, just understand that we have this medical note, and I think this is in Polish. Okay. So we have this medical note, and what is done at one part of these emergency departments in healthcare. There are a section of clinicians or even doctors who spend a lot of time from their main work of like acting, entertaining patients and doing surgeries and doing all this medical stuff. They spend a lot of time doing these sort of annotations, okay, from these medical notes. And because these annotations, and why we cannot do it automatically, because these particular annotations require clinical expertise. So you and me, even if we are working on NLP for maybe 5, 10 or 15 years, if we do not have the clinical knowledge, we cannot do this type of annotation task. If you give me to annotate a sentiment data, I have worked my PhD on sentiment and emotion. I can easily do it. I can do it. I cannot say I can do it in one day, but based on the number of samples, you can do it. But if you give me the same data, I cannot do it because I simply lack the clinical knowledge, okay, to do this type of annotation. And it has to be done by clinicians or medical experts. So doing their work on like doing acting to the entertaining patients, doing surgeries, writing medical records, and doing diagnosis and everything, they spend a lot of time doing this type of clinical annotation. Okay, so what this clinical annotation looks like, say for example, this is a medical note, and somehow I don't understand Polish, I don't read Polish, but say for example, if I am a clinician, I'm acting a clinician, okay, and I read this context and I understand it is talking about tumor site, location is intra-abdominal, and it is retroperitoneum, something clinical, which I don't know. But this is a type of annotation that had to be put in by a clinician from their clinical expertise, from their clinical knowledge, okay, which is nowhere in the original input. This is very important. This line is very important. This is something that is nowhere in the medical input, original input. It is something that was inferred or judged based on my clinical expertise that I have gained over the years from reading this medical note. So now if I say that this is a information extraction task, tell me anyone who is here, that which task or like which information extraction task you think that this is much related to, or whether there is direct relation to any particular information extraction task. So if you do, like, just to say, I don't know if most of you know what is information extraction task in general. Like, there are tasks like summarization, which many of you know, abstraction, named entity recognition, and then this type of task come under information extraction. Now if I tell that
This annotated note, it's not in Polish, it's in English. The blue.
the annotation, okay, this is a good question, but the annotation is English because we want to have a common repository which everyone can use. Okay, it's not only, it should not be like it should not be restricted to only Poland. So okay, the broad scope of this idea for RC project is that it concerns around 13 to 14 European countries. Okay, so and if you know, like in Europe, there are 21 countries or 22 countries which come under a common unit, which is Schengen area. So there are 12 to 13 institutes or from various all these European countries. They want to do this collaborative work and come up with a common data model for rare cancer, or common repository which holds data about rare cancer, which holds NLP tools about rare cancer. Now, to have a common repository, you have to have a common language, because I cannot expect from an Italian to understand Polish. Okay, all good. So that was the main reason why the annotations are done in English only for any language. And the scope of this project is multiple languages, which I will tell later. But this is a very good point raised here, that why it is in English. The English is only because just to have a common repository, shared repository among all the European countries, most of the European
Just
countries.
like we make a normally lexicon in normal.
Yes. No, but even for lexicon is also dependent on the language. So if you want to do something on Hindi data, you cannot use, like, you cannot effectively use English lexicon.
Yes.
Right. But say for example, how to explain this?
As a common reference.
Okay. So if I say, for example, this same medical note is you have the same medical note in Greek, same medical note in Italian, and same medical note in Slovenian. Okay, and everywhere in their own language, something related to this tumor site and retroperitoneum will be written. Okay, and we want to have a common annotation for all these cases, so that it has. So say for example, from India, if we want to use this model, we should not be like feel left out, that okay, we do not know Italian, we cannot use this data model. The annotation is in English. Okay,
Means
so
Latin script here.
Latin script, yes.
Yeah.
Okay, so it has to be fairly shared among multiple partners, and it does not consider India in the scope, but at least they consider their own European countries for this particular purpose. Okay, but but the idea is again same. We can think of something similar if we want to construct among, because we do not need an European model which only supports 12 language or 13 language, because in India we have already 20 or 20, greater than 20 official languages. We can have our own model having English or Hindi as a common this annotation language, right? But the main idea is same. Now, I think the task is clear. The task is that we need to do right now. These clinicians are involved with this task of putting annotation. Yes. Any questions? I saw someone raising a hand before, but I don't know now. Are there any questions right now?
I don't think so.
No,
Living has
sir, me only, and you have answered.
Okay. So just now for this next 3 slides, let me just complete, and then I will again give scope for questions. Okay, but I think it is very easy to understand. So now the natural way to that comes in our mind, that we just know how to train machine learning or deep learning models. Okay, we have this node. We know that this should be the output, and we take an LLM or even BART or any model of your choice you take, and we give this input as medical node, and this will be our Y, like X and Y. X is the input and Y is the output, and we solve it as a supervised task. I'm not going into whether it will be classification or generation, but it is a supervised task. Okay, this can be a natural way to do so. So this is annotated note. Do we already know that what to be expected? That gold annotation is this one, and we can train an LLM, and we can expect this clinical annotation to be this one. Okay, this was our initial perception. that to go ahead with this topic, with this objective. But the challenge is that we do not have the annotated note. But we only have the original note, which does not, again, I have said that which does not have the clinical annotation within it. It may or may not have. I'm not saying, so there are many type of annotations I will show you later. But for this particular case, the tumor site intra-abdominal, it is nowhere in this note to be found. So now you see that if you see the traditional information extraction task like summarization or abstraction or question answering or name entity recognition, all these cases, the output is somewhere in the input. We know for sure that the question that I'm asking, the answer is somewhere in the passage. Okay, so in this case, it is not neither summarization nor abstraction nor name entity recognition or something like that. So naturally, we do not have a SOTA available, or state of the art model is not available here. Because of that, why? Because the output has to come from our clinical expertise, which obviously LLM are not clinicians. But the task that has been put on us is that we have to develop a LLM for this particular task. This is a challenge. Okay, so this is not the overall project. The project is huge. It has multiple modules and a lot of other things. We were working on a very small module of NLP in this particular project. There are many other things, ethical issues, law and all everything. But we are talking about a very small aspect in the NLP part of the project. And one part was that the challenge is that we need to solve this using LLM, having clinician level expertise, which is very difficult. Okay, I think I have motivated the problem quite well, and the challenge is quite understandable right now. We do not have annotation available. We only have the original note, and we have to magically come up with this clinical annotation using an LLM. Take your best LLM possible. But even there is a restriction. Why you cannot take even if I give you a lot of dollars to spend on procuring license, you cannot take the best LLM, because ultimately the system that you will develop has to be deployed in a hospital or a small clinical center. You already know, I know that KIT is quite well furnished with equipments, but even if you go to good colleges, top tier colleges, you find it a lot difficult to get access to GPUs, even procure GPUs. Okay, we cannot hope that an hospital or a clinical center will just say that, okay, you procure me this particular GPU configuration and they will be getting a GPU. They will not get. So they will give us a system maybe having 4 GB VRAM or 8 GB VRAM or 12 GB VRAM maximum. So your solution should be working in that particular scenario as well. Okay, so now you see that how these challenges, multifaceted. It is not only the type of data, it is also the type of problem that we are solving. It is not a pure information extraction problem, but also then we cannot use the best of LLMs, recent LLMs. Okay, because there is a constraint in the hardware resource as well that will be in the that is there in the deployment setting. All these things need to be kept in mind. Now, for now, let's talk about the data part. Then we will again go back to the methodology. So we were handling data across 3 languages, that is Polish, Italian, and Swedish. Okay, and all those are cancer-related data, sarcoma and head and neck cancer. But we do not need to go into details. But the Polish data was had the least number of samples, only 1126, and the most number of samples were for the Swedish data. That came from the VGR is an institute in Sweden. INT is the biggest hospital for tumor in Milan, Italy, and MSCI is in Poland. So these are the 3 hospitals that were collaborating to help us with the data for the NLP. And ultimately, our solution will be deployed in their own centers. Okay. I'm skipping this slide. So anyway, so there is a tool known as CliniNote. You can search by this term. So it is extensively used for doing medical annotations, and physicians generally use CliniNote to do the annotations that I will show in the next slide. And when you download files from CliniNote, it generally exported in JSON format, and it exports 4 files for a particular annotation. Okay, so one file holds the actual annotation, one file holds the structure of the annotation. Okay, that is the definition. Another file holds the note which was annotated, and another file holds the highlight, which is out of scope for now. So when you use CliniNote, you get the data in JSON files in 4 categories. So to help our model building, what we did initially, we wrote a very easy Python script to consolidate all this data and bring it into one umbrella. Okay, we build this whole 4 JSON into one CSV, single CSV. This is a single data point that I was discussing before. This is a single data point. So A, B, C, D. So because of the size of the node, I had to put in this way. But think that it is in a CSV column format. So A, B, C, D, these are the columns in the CSV. Okay. And the most important columns are this original text, this one. So this will be the input to our whatever we develop later. Okay, this is the input. And the expected output is this one, patient's gender, male. Okay. This annotated text is here just to understand, just for reference, but it is nowhere to be considered as an input to the in the development phase. The input will only have original text, and the expected output is patient's gender, male, for the annotation type gender. See, now we have all these sort of annotations that we need to do. Annotations related to tumor, annotations related to surgery, histological type, status of patient, then patient's gender that I showed in the previous slide. Likewise, so there are more than 25 annotation or entity categories or annotation types that you need to do using LLM. Okay, and this is the data distribution across these various annotation categories for these 3 centers: MSCI, VGR, and INT. Okay. I have already motivated why this task is challenging and why there is no SOTA available. So the best approach that seemed to work the day when I at this left FBK was that, and it evolved. So the thing that I am discussing is very straightforward, but it was not very easy to reach to this stage because it took us more than, I think, 1.5 years to come to this stage, because it was it was a lot of trial and error that went into the process and refining the data, understanding and again modifying the structure of the data. And every time you modify a part of the data, all those, like that same structure has to be maintained across all the annotations. So it took a lot of effort and also.
Yes, hello. Mute. Sorry, sir. I am muting everyone.
Okay. So anyway, so I'm not going into the struggle that we did, but yes, so the thing that the methodology that seems to work right now with some good performance for most of the annotation type is this one, which is prompt-based few shot in context learning. Okay. For few cases where we had sufficient number of samples, we were able to do fine tuning, but for most of the cases, it was pure prompting, but with some clever choice of few short examples that was put in the prompt. And it was done using a straightforward RAG strategy. I'm not going again into details of the RAG strategy because it was very simple. It is not something that it is very difficult, and I'm not discussing, but it is very straightforward using cosine similarity measure. But it was bit of some wittiness we did to extract out the most relevant few short samples that was able to support the prompt for the LLM to understand. Anyway, the first part of the prompt was a task description. Okay, so you can just give a quick read. So we just tell that this is a task and you will be given a medical note, and we expect the output in a structured format, in a structured format with the relevant information. Now, in this task, you see that it is not only just coming up with an annotation. The task is, there are 2 tasks merged in one. The first task is that, so there can be, so say for example, let us take the case of surgery. So in surgery, it is not a single type of annotation we are trying to refer. In surgery, there can be many types of annotations. You may need to annotate surgery margin. You may need to annotate surgery location, surgery date, or type of surgery, or whether the surgery was complete or incomplete. So all these cases come under surgery entity. So even in one entity, there are various type of annotations possible. So now the task is that the LLM must find that which particular annotation type is there in the input medical note, and for that which particular structure of or which particular output template suits that particular information that is to be extracted. So say for example, if I provide a medical note and it does not have most of the information that is shown over here in the templates, but it has the surgery margin. I want it to find the surgery margin and put it in the relevant place in this particular template. That margins after surgery R1, R2, R3. Something like that. So it is not straightforward that it will clearly know that it has to output only this single type of annotation. So there can be multiple type of annotations within a single entity being the surgery. It has to come up, it has to be see that what exactly is there in the given input, what we are trying to make it understand that what I actually need. Maybe I do not need surgery date or result. I need surgery margin. So it should come up with surgery margin from the input and put it in the relevant format and give us the output. So that's why the task is even more difficult when you try to evaluate the performance of a model. Because it is not a classification, you do not have a label. Or it is not a plain text that is generated and you do a BERT score or a BLEU to find out the quality. Because the structure has to be intact. So if it is surgery, if it is margins after surgery R2, it has to be outputs has to be margins after surgery R2. It cannot be just R2. Even it is correct, R2 is not wrong, but it is missing the structure margins after surgery, because this will go directly into the field of a clinician's entry or journal book. Right. So this is the difficulty of this task, and that's why, although it is very much dependent on prompting and few shot engineering and also RAG based approach, but it took us a lot of time to understand that how or and when LLM is failing, and in which ways, in which cases it is failing, in which cases it is doing well. It can do better if we support it by somehow. Okay. And over the time, like, we reach to this final strategy, and fairly it works well. So now another challenge is that because there is so much variation and diversity in the type of annotations, we cannot develop a single script or single prompt for to able to annotate biopsy mitotic count, and that same prompt to annotate histological type. Because if you see the output annotation structure, they are all different. They belong to all different type of medical entity, clinical terms, and everything. Okay, so that's why for each annotation type, there has to be a separate prompt available. And wherever there is sufficient data, you make that prompt, you pass that prompt through a fine-tuning stage. Okay, so that's why if there are 25 annotation types that we want to handle, there has to be 25 NLP or prompts that should do this task separately. And this 25 annotation is there for each of the centers. So we have 25 prompts for Italian, 25 prompts for Polish, and same for Swedish. And since there is a difference in language as well, and also the structure of the annotations also vary to some extent for the languages, you cannot directly use all the 25 prompts for all the three centers. Because most importantly, if you remember this slide, you see that some annotations which are there in the case of Italian INT, which are not there in the case of MSCI in Polish. So naturally, so those particular prompts has to be developed for INT only. Okay. Again, for some part of Swedish data VGR, there are some prompts that we do not require, but we have for the other two centers. So then, so that's why there has to be a lot of work that goes into the prompt refining, fine tuning, and everything. And this is a small example. You have this only input node to the LLM, and this is the prompt that we are using for this particular. This is a very simple case where the value is directly, it should be directly mentioned somewhere, like here 5 out of 10 HPF. Okay, and we did not need fine tuning in this case. Okay, but for many other cases where there is sufficient data, or the type of annotation is quite complex, we needed to do fine tuning a lot. For this particular case, or maybe a case for identifying patient's gender, we know that LLMs are already quite well versed in understanding gender from textual data in general. So for that, we do not need fine tuning. For this particular case, this prompt was sufficient with some obviously support of some few short examples, which we chose through RAG, and it gave us a correct output in the particular structure, biopsy mitotic count 5 out of 10 HPF. Same goes for the other script, other type of annotations like this one. Now I will show you some, okay. So now, as I said, that what will be the metric to evaluate is that how efficient your model is performing, because you cannot do direct, you cannot do like semantic matching of two, like the generated text and the expected output, because semantically maybe it is correct. Okay, maybe you can say that angiosarcoma is the histological type, which is not wrong. But I do not want in this structure. I want exactly it to follow in this particular template. So for that, you cannot do semantically, or you cannot use metrics that support semantical similarity. You cannot use cosine similarity directly. You cannot use bar score directly, right? So in this case, so that is even, and this is something that we did not handle. We are not able to handle. No one knew that what metric would be suitable. But what we came across, that we can take two kind of parameter, and we can measure those parameter and see that what is the output for those parameter. One is exact match and one is partial match. So if we see the expected annotation is exactly what the generated annotation is, then we call it an exact match, like explained over in these two cases. And if we see that the part of annotation, or what we were expecting it to the LLM to annotate, the part of it is correct, then we, and obviously to some certain confidence. We cannot say like if it is matching only one word, and if that one word is not the actual annotation but the structure, we cannot say it is a partial match. The partial match should be accounted to the annotation. So here, if you see, the histological type is just a structure of the template. The actual annotation is this one, undifferentiated sarcoma with some ICD code. Okay, so if we see that some part of this undifferentiated sarcoma 8805/3 is correctly generated, and to certain extent, and that certain extent, or to understand the confidence, we use cosine similarity. And that cosine similarity is not set to the same value for all the cases, because for histological type it can be certain threshold after which we can feel that okay, this is acceptable. For maybe this patient's BMI, this case, the threshold can vary. Okay, maybe if his patient gender male, okay, we cannot, there cannot be 50/50, there cannot be 40/60, it has to be 100 out of 100. So we cannot consider, for patient's gender detection, we cannot consider partial match, right? For those cases, it has to be exact match. But in these cases where there are multiple entities to be annotated, okay, there is a patient BMI, then there is a patient, there is a date on which the evaluation was done, and maybe one of them it is correctly generated, we can say it is a partial match, right? So this is the need for partial. So this is a very good case that there are cases where there were at least 4 to 5 type of entities that has to be put in a single annotation. So this is a type of chemotherapy that is pre-operative. It can be post-operative as well. Okay, it can be curative. It can be palliative as well. This is something that I worked on, so I know you do not need to worry about. But it can be multiple, like curative or palliative. The date has to be the same thing. Then there is a clinical term or composition that is mentioned. So how to know that when to say it a partial match? So maybe we have said something, anything about 0.75 is acceptable. So if we are getting an annotation generated with 0.75 cosine similarity, and we see that out of 4 annotations, like here, here, and here, maybe 3 of them are correct or 2 of them are correct. And we know that this is a very challenging case, this case of chemotherapy. We should be happy with it. But now, should we consider it directly in our clinical implications? No. It has to have some human expertise or human in the loop in the process. But if we are going for some easy entity where we are naturally getting 95% confidence, and that particular entity is not that much risky, okay, to handle, or it does not carry serious implication, we can take that generation from the LLM, and we can directly put in the journal of the clinician, right? So these are some results. So we are now moving on to the last stage of this particular discussion, and these are some output. This particular case for surgery, and initially when we started this, almost 2 years back, and that time we started with Llama 2, and even we started with, sorry, we didn't start with Llama. We started with encoder decoder models like T5, Med T5, medical T5, and other T5 variants, multilingual T5, and all. Then when Llama caught the eye, and we also had managed to get some good GPUs and all, so we started with Llama 2 at the beginning, and then we moved on to Llama 3.1, 8 billion, Llama 3.1, 8 billion instruct, and this is somewhere we stopped, because at this particular stage, and 8 billion was something that was able to be supported in the deployment scenario as well. In the clinical center or in the deployment setup where the models will be used, they could give us a hardware that could support Llama 3.18 or any model with 8 billion parameters, not more than that. So that is so our hands were tied to some extent. Our hands were tied in other aspects as well, like the type of data, the type of problem we are solving. But still, we managed to perform, I would say, like quite well for most of the annotations. And I will show quickly the overall output. But these are some annotations some raw results that we got from the output from the LLMs. This one is patient's weight 80 kg, height 170. This is a very easy case because this has to be there in the medical note. There is nothing to be inferred from clinical expertise. So this is plain extraction task. You can say this is a direct question answering kind of thing. Okay, but here the only challenge is you need to put the relevant output that you are getting in the correct structure. Okay, but there are not so easy examples. Say for example here where this ICD code, this histological type may or may not be there. In most of the cases, ICD code is not there. So there has to be some ontology, there has to be some, it can be done through a knowledge graph if we are able to build a knowledge graph with the ICD codes. But right now there are none. So naturally, you see the performance of LLM, it is identifying the histological type correctly, but it is making error in the ICD code. Because it does not know that 9045 means this one. Okay, but I think this can be easily handled even if you just maintain a dictionary with this histological type and their ICD code and you do a post processing. Or for a serious, much more mature research, you can extend this work on a knowledge graph to have a ICD ontology on a knowledge graph, and then you can use a knowledge graph to support your decision making. This is a very interesting correlation. On the right, the bars show the number of annotations for these various type of entities. Okay, so beam quality has less than 25 number of annotations. Then histology subgroup has most number of annotations around 175. And parallelly, you see the performance of accuracy for those particular same annotations. And now you just see and you can understand that there is no clear correlation that if there are more number of annotations, the accuracy will be higher, which even was my expectation. That if the histological type is highest, then the accuracy should be highest for histological type. But if you see for this one, systemic treatment start, it is getting almost okay. This is a case for it is an outlier. Okay, this is 100% performance achieved even with less than 25 samples. Okay, so it is a very small sample size to say that how the performance is there. But say for example, if I take this tumor site has achieved around 60% of accuracy with having 150 number of samples. But if you see that you are getting more than 60% of accuracy for surgery margins with less number of samples, less than 25 number of samples. The reason being, maybe the task itself is very easy. The reason being, maybe the annotation is already available in the medical note. There is very less inferencing from clinical knowledge that needs to be done. Or in general, where the performance is bad, even where there are more number of annotations, is that maybe the task is very challenging, or in the given particular annotation type, there are more than 2 or more than 4 number of entities that needs to be put in the template. So there are multiple trade-offs. So there is no clear correlation between the annotations, number of annotations we have, and the amount of performance that we achieve through this approach. This is something that is also shown through this graph. You see that, okay, so if you go towards the right side of the x-axis, that is the number of annotations are increasing. And if you go up towards the y-axis, then the accuracy is increasing. Now, the natural goal, the natural idea should be that somewhere here, wherever there are more number of annotations, like here, the performance should be somewhere here in terms of accuracy, right? So if the number of annotations for patient's gender and tumor site are sufficiently good, okay, then why the performance are in around 60 and 70s? Why not around 80 and 90? But where if you see this cluster where the performance are above 80% of accuracy, and if you see the number of annotations, they are all less than 100. And exactly these are because of the other reasons that I told you. Maybe the type of nature of the problem is easy, maybe it is directly available from the input, or maybe there is only one variable needs to be annotated. Okay, but here maybe in tumor site or surgery type, there are more number of annotations need to be, more number of variables need to be annotated within a particular, in one shot. So this is the overall performance that we ultimately achieved. So across the centers, Polish, Italian, Swedish, okay. Italian had two subdivision, one for two type of cancer, one is sarcoma and one is head and neck. So that's why there are two split for Italian. But ultimately the performance achieved was, overall performance was achieved was around 70s or 75, you can say. If you remember, MSCI had least number of data, least distribution, 75, still we managed to achieve 75%, whereas VGR had most number of data, where we achieved 73% of over average accuracy. But I would more rely on this performance than on this performance, because this performance is representative of only 1,000 samples, whereas 73% is representative of samples of 10,000 plus cases. This is the overall accuracy for all the variables. But now if we see the top performing models for all the centers, so the top performing models mean wherever the accuracy was greater than 60%. And if we only consider those models, so their average accuracy was 85%. And at least around 80, above 80 for all the cases. So if you mentally set a threshold, and this threshold was not set mentally by me, but it was after discussing with the clinicians that we discussed that, okay, if we are able, or if, because the task is so challenging, and this is an more of an exploratory problem, incremental problem as well, although the project ends this year, or I mean, it has already ended, but it is in an extension, but the work will carry on, because there has been a lot of good intakes that we took out of this over the past 3 years that we worked on, and there are more there are more potential that we already identified that can be worked on, adding more data somewhere, maybe enriching the annotations that we already have, and similarly maybe also strengthening the methodology. But if we see that, if we consider the LLM performance above 60%, we should be happy. Then if we, for those models, the average accuracy is 85 for MSCI, 81 for VGR, that is for the Swedish data, and for Italian it is 83. So near about 80, we can say. Okay. This is just par annotation performance that is shown, but I think we are in the last few minutes of the session, so I'm skipping this. So the open issues and challenge, I will just quickly say, the first one is sparse data. So from the initial heat map, if you remember that there were many number of annotation types and spread across the three centers, and also the distribution was very diverse. So if just for now, just believe me what I'm saying. So for the Swedish data, although there were 10,000 samples, and that was highest in number that we got from the three centers, 6,000 samples belong to only one category, that is tumor site. And the remaining 4,000 samples were spread across 24 or 23 or 24 annotation categories, like surgery, chemotherapy, radiotherapy, surgery margins, patient's gender, patient's BMI, and so on and so forth. But out of like 6,000 out of 10,000 belongs to only one category, tumor site, whereas the remaining 4,000 contains or holds 24 types of annotations. So there is a huge sparsity among the data. Another problem is that because of the sparsity, some type of annotations are very scarcely represented. Maybe for, say, for example, new cancer topography, we have just 5 samples. Even if you use few shot, because it is challenging, even 5 samples cannot help the LLM to understand what new cancer topography is, because it is from a rare cancer domain and it is very challenging in nature. It is not just pure extraction. Right. So these are the two very serious challenge, that because of the sparsity and low representation of few categories. Another interesting thing we noticed while doing the experiment is that in few cases the LLM was doing perfectly fine, like with 100% accuracy. Okay, but in the gold output, I won't say it is wrong, because initially I believed it was wrong, but after discussing with the clinician, we understood that in a new language, okay, say for example in Polish, in English maybe it starts with, the note starts with the patient's age is 64. So there is no clear hint of male, female, something. In Polish, there can be very neutral term, but in Poland, in Polish, or a Polish speaker can identify from those two words that generally we like we have an idea, like it's a generally names ending with A. Okay, let me take my name, Soumitra. In Bengali, it is Soumitro. Even in maybe Odisha, Odia, it will be A is pronounced as O. Okay, but if I say Soumitra to a Hindi speaker, but I write A at the end, they will say Sumitra, Soumitra, something. I have heard a lot variation of my name, okay, from childhood. So they will say Soumitra. So ending with A means these fine differences are there in when we move from one language to another. And it is not a fault of even ChatGPT or this Llama 3.18 billion. They are saying that it is neutral in nature. The gender detect is neutral. But in the Polish language, for a Polish speaker, they can clearly say, no, we generally use this term to identify a male patient or to understand that the patient is female. So then whose error is this? So these are few interesting corner cases that we found. And another last thing that is that genuinely there are missing cases of dates where is mentioned where it is not mentioned in the medical note anywhere, but the annotation that was expected from us is to give a date, and that date was coming from some metadata of the medical note, which is totally unknown to the Llama 3.1. Okay, because Llama only we gave Llama only the medical note. We didn't give the metadata information or on which date it was performed or anything. So this date should come from the metadata. So this is a genuine, this is not an error of the LLM because it is not able to find anything because it cannot infer a date. Medical terms can be inferred from the reading the medical context, but a date cannot be inferred. So date has to be there. If it is not there, it is outputting, it is not there. But the gold annotation, the clinician expect us to give a date. But because for the clinician, they see the whole metadata along with the medical note. But for us, we are only working on the medical note. We do not see the metadata. Okay, but these are these are not very serious issues. Anyway, so I think it's time. So I would stop here. So we can take a few questions if there are any. Okay, so just to sum up, like the part that I discussed in the first objective that I discussed are already there. You will find in these references. And here are some three, not directly related, but recent works that we have worked on from various domains. One is on with visual language models, and then one is on stress and triggers detection on social media data. And another one is on complaint analysis and sorry, self-harm and complaint analysis. So you can just take a look. So now, yes, so we can take a few questions if we have time. Hello, am I audible? Am I audible? Can anyone confirm if you hear me? I don't hear you. I don't know. Okay.
Hello.
Yes, yes, I can hear you now. Yes, yes. Do you hear me?
Yes, Lipika ma'am. Yes, I'm just on.
I think there was an issue with the network. No, I was not muted, but yes, I lost you anyway. So we can have any questions if we have time.
Yes, yes. Lipika ma'am, you can unmute yourself. You can ask the question, or you can unmute. Yes, Lipika
Yes,
ma'am.
I was not able to unmute, sir. Yes, sir.
You can ask your question.
Yes, sir. Thank you so much, sir. Hello, am I audible?
Yes, 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 I can hear you.
Yes, audible.
Yes, sir. Sir, really, I'm feeling really honored and grateful today attending your talk because I'm working as an assistant professor at KIT. I'm Lipika and I'm pursuing PhD at IIT Indore. So most of the papers I follow, sir, viewers. My work is aspect-based sentiment
With whom
analysis.
you are working in IIT Indore?
Chandresh Maurya.
Okay, okay.
Dr. Chandresh Maurya.
Okay, okay.
So mostly I refer papers of Gopendra sir. And I found you, and I was also
yes,
in
yes,
that.
we have a lot of common research areas.
Yes. In fact, that.
Yeah, so mostly like during my PhD, I was more interested on working on social good topics.
Yes,
So if you if you are aware of the special themes in these good conferences like ICHKAI and AAAI,
Yes,
they generally update their various tracks for accepting papers, right? Like
yes, sir.
sometimes on mental health, sometimes on
Yes, sir.
clinical.
Just recently started
Yes,
working
yes. So
collaboratively
those are very
regarding.
good venues, and those
Yes,
actually were my like one of my interests when I was doing my PhD. But also I was a project fellow, so I was working on a CDAC project. But that actually brought me to this area because that actually required me to work on suicide notes, on forensic document in general. Okay, so that is where I jumped in this area. But I think it is quite interesting and lot of works can be done.
yes,
There is
sir.
huge
Yes.
scope. Hmm.
And just I'm slightly jumping to the track from sentiment analysis towards mental health, women abusement, child abusement. It's really very tough if this
Sentiment
annotation
erosion
comes.
has already been worked on a lot now. So I think we should naturally move to, yes, these topics that you just mentioned. Even trustworthy AI and ethical AI is a
Ethically.
very
That too,
concerning
this
issue.
multilingual, low resource Indic languages.
Even in
Yes,
Indian context, it's very good. Low resource Indic languages.
yes, sir.
So, and now that you have the backing of the government, government of India, that they are putting so much stress in development of AI and all. So I think even it is very good time to write good projects on this particular topics.
Yes, sir. So my simple question, sir, just for benchmarking these small projects like benchmarking women abusement or benchmarking child abusement, what the most typical things to sell out in the paper like AAAI and coming this?
Uh, s- mm,
Because
okay.
recently my one paper accepted in ACL 2025 as main paper. It was in code
Oh,
mix.
very good.
Yes, sir.
Very good.
And one paper at expert system and last
Okay.
year one paper at calling Abu Dhabi.
Okay. Okay.
So
Okay.
now it is driving me towards our Indic multilingual language.
Mm-hmm.
So what happens, sir? For PhD, you are bound to go for the single downstream tasks. You cannot have multiple projects.
Uh, No, but I mean, okay. So how I did it, I don't know. So if you just follow, not just in details, but follow some of my papers of my PhD, you see that they span across multiple topics.
Yes, yes,
But
sir.
the idea, I mean, the motivation idea came from my PhD supervisor Asif sir,
As if
that
you.
there has to be a common backbone. You have to write a story across a line, across a common backbone. And for me, the backbone was emotion and sentiment.
Yes, sir.
And
Yes.
say, for example, this is my example. You can take any example or also from your understanding. But what I did, I kept that emotion and sentiment intact for all my papers, all my work.
Yes, sir.
Then I started exploring various other things like stress, mental health, then complaint and everything, but keeping that emotion as an important factor, like emotion aware sentiment model, emotion aware
Yes.
mental health models like that. So no one is so you should be a bit uh, uh, you should think in a way. Obviously you cannot work on two diverse, like one you cannot work on summarization then you jump on classification.
Yes, yes,
Okay,
sir.
but you have to have a common backbone, and that you can do again. We all have that common we are smart enough to find that common backbone and then try to explore other areas keeping that backbone somehow intact. Then we are free to explore many other areas.
Yes, sir. Yes, sir. Asif sir was also
And for the
suggesting me last
yes,
time
yes,
when
yes.
I went to triple IIT Mumbai ASL.
Uh-huh.
So sir was telling diverse your
ASL
tasks.
was this year, last year in Bombay.
Yes, Mumbai.
Uh-huh.
Yes, sir. Yes, sir.
Oh
You
yeah,
were
so
not there.
no, no, no. I was outside and I didn't send a paper, but I was at that time outside. But anyway, so you're coming to a question that how to
Benchmarking.
benchmark. Okay, so as I was saying that if you are trying, it's always good. Okay, so the topics that you mentioned or the domain that you mentioned, like self-harm or mental health or women's related something. So
Yes.
all these are social good topics, but all of them carry a lot of like you as a researcher, you have to carry some responsibility. You have to be ethical. You have to
Yes.
have some responsibility. You have to be very careful on what you put in the paper.
Yes,
Even
sir.
if you are creating a data set of 5 samples, those samples should not have any high-end implication or bad implication to us as a society.
Yes,
I
sir.
am not going about getting flagged or black marked, or that is something different. But I am talking about purely from the point of acceptance and rejection. So if you are working on these areas, it is comparatively easy to get good publications at good venues, but only if you take care of all these things. It has to be well researched. It has to be you mention all the copyright things. You do give a proper licensing.
Yes,
You
but that copyright from where I to get? Because even my annotators, those all are boys. I'm also not feeling comfortable that kind
no,
of
no.
reviews
It's not.
also.
It's not. It's not
Yeah,
related to like whether the annotator is boy or a girl. It's not.
yeah,
I'm taking that once you publish the paper, or say for example, you have created a resource, okay, and also you have designed a methodology and you write a paper in AAAI. And now you have to be very clear that you know that what your data is. Okay, so say for example, I take the paper that is with Gopendra, and I think you have taken a look that is on
yes,
self harm.
yes,
Okay,
yes. Self
self
harm is
harm and also
suicidal things.
previously on a women's data. So
Yes,
I know that what type of data we have annotated, what type of pictures are there, what type of text that is, what type of language is there. I know. Okay, so
yes,
based on that, I should decide that whether it should be publicly or freely available for download in the public forum, or it has to be gone through some licensing. Licensing in the sense you can restrict the licensing. Say, for example, if you have some, I don't know, if you have some way through your institute that, like we do have through IIT Patna, that if someone places a request for the resource, and if it is a non-privacy concerning resource, then they can directly click the link and download it. But if it is a privacy concerning, like most of my works are privacy concerning. So like suicide and all, we
yes,
have developed a suicide like no corpus, sentiment analysis corpus on suicide notes. So we
yes,
cannot allow anyone and everyone to download the note directly. So
yes,
they will put a resource, they will put a request. Somewhere in the backend will review the request, like it is there for other good institutes as well. And then if you feel based on the details that they have put, that how they are going to use the resource, how what are their affiliation, whether there is an undergraduate student or a faculty member is asking or a PG student is asking, and then you decide or your team decides that whether to share the resource with them. This is in the point that how to disseminate the resources. Now
yes,
coming to the research part. The research part, in that you have to be really meticulous, and if you are getting things done, like if you, whoever is working on that, so you are the most mature person and under you supervision everyone is working on. But
yes,
I believe that you are well aware of the responsibility and the implications that might have if something goes wrong. But
yes,
that has to be ensured that whoever is working with you, even if it is student, boy, girl, doesn't matter, or even it be the annotator or someone, they also understand the responsibility and the seriousness of the topic they're working on.
yes, sir.
Otherwise, you don't know. Maybe they will report to you, yes, ma'am, I have completed all the annotations, and this is okay, and it is not possible for you to.
Fortunately, one thing is Reddit freely available. Actually, using the keywords, we are
Yes,
scrapping
yes, yes,
or manually just copy pasting in the sheet, then annotating.
yes.
So that is one way. Thing is that, sir, that in India, two things happen. If you are going for this such A star value papers, benchmarking is quite easier than the technical novelty framework. But
Mhm.
journal, when you go for journal, they don't give weightage to the data set papers, isn't
No,
it?
no, 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 no.
Yes.
You are right. You are 90% right. But only if you do not know that there are certain journals which are only made for resources. If there are certain, so you know of LREC, right?
Yes, all right. Yes.
So LREC calling are being done together now. So LREC is purely for resource oriented, but it is a conference. But
Yes.
there is a journal variant of LREC, which is
LRE.
LREP,
Yes, yes, sir.
which is where we put our data, in which we put our paper for the first objective that I discussed today. Because it is a total data centric paper, where we're
Yes.
creating resource through some
Even
methodology.
IEEE transaction KD is also taking benchmarking
Exactly.
for
So
global
they are like
benchmarking.
for even for IEEE, for ACM, for Wiley, there are even for if you go to Nature journal like scientific report and all, scientific
Yes.
report is multidisciplinary. They
Yes.
they will take any type of paper.
Yes.
It has a good impact factor. But if you know that there are, if you obviously if you now if you publish a pure
Now,
data
this
centric
is
paper
also
in.
fascinated, sir. If you are working in unimodal like text, people will give more weightage on multimodal, even if the work is
That,
low.
that is a trend. You have to go with the trend.
Trend. Yes, yes, yes.
So that is why it's good to that it is good that you have published in ACL, you are following it double ACL and calling. That is why I think like in KIT it is a culture, I know, but even in the premier institutes or there is a common norm that we generally tend to give more weightage to the journals. Okay,
Yes.
even in our evaluation or appraisal, everything,
Yes.
which
Yes,
is
sir.
not the case outside. Okay,
Yes.
in foreign or even in good institutes, or even you come to AI NLP lab, IIT Patna, and that group. So there is where I first learned that conferences are supreme, although they are not well judged or well valued in Indian community, research community. But
Yes,
that
sir.
is where you learn the most. The most recent breakthrough works are being published in journals, not in in conferences, not in journals. Sorry,
Yes, sir.
in conferences, like in AAA, ICHKID, CVPR, ICLAR, those papers.
WCCV and
Huh, WWW and all. So, but obviously we need to also publish journals. And I'm not saying, okay, you publish in TSCL. That is very good. And it's not easy.
This is far way to go, sir. If you say
No, no. So
TSL
if you
farming,
say that, okay, it's easy to publish in
I'm
journals,
just
then
a
we publish
part-time
in TSCL,
scholar.
you publish in affective computing, transactional affective computing.
Affecting, yes, yes, sir.
Okay, so when I was in my first year, I dared to submit in affective computing. Okay, and obviously it was rejected, and I didn't have any idea at that time.
When I put a paper on Tally, it's a 7 months, but no reviewer.
Talib takes a lot of time. Talib takes a lot. Even knowledge-based system, it varies. For me, I submitted a knowledge-based system. It took 1.5 years. So it is not in our hands. Even if you submit in LREV will generally takes 1 year time. But I know of cases where it has been given like the output came in 3 months. Anyway, so that is not our job to think of. We should we should know the proper venue for which our work is there, and we should submit in that venue only. We cannot write a resource paper and submit to ACL, or we cannot write a resource paper and submit to polling. Okay.
So any questions? Any other questions? Okay. Okay, sir. Thank you very much. I think we should stop here.
Okay. Thank you so much. Thank you
Thank
for
you
attending,
so
everyone.
Thank you, sir. We'll
Okay,
talk
thank you.
later.
Okay,
I'll
okay.
contact you.
Have a good day. Bye bye.